Hello everybody, welcome to the tutorial on the fractal tree. Let's see how to make all these fractal trees and the blueprint behind each of them. Let's start from the first type of tree, the basic unary trees with one mother, one child. If you have purchased the FractalTreeVol1, you will have all the blueprints in front of you. There are 10 blueprints, and you will have also the mesh I've prepared before to generate this showcase here. So let's go to the fractal tree folder here and let's start with the first blueprint. I will start with the basic blueprint, the one mother, one child. When you drag it into the scene, you will see that it already has preset information. You will go on the right on the fractal tree editor and parameters, and you can start changing these parameters. The most important thing I didn't cover in the other videos, the presentation videos, is this part of the mesh. So I want to go directly to this part here so you understand how all these meshes stay together when we make rotation or torsion or everything else, or we scale them, or we put more levels inside. Let's go to the first mesh, the cube one. So this is a static mesh, simple static mesh. The only thing is that to make all these rotation and resides and everything and keep all the mesh together, I used these sockets. So this was a great idea I had some months ago, and it makes all this fractal tree blueprint code working. So for each mesh, in this case I'm speaking about the basic tree, the unary tree, you have to create a pivot socket which is on the pivot of the mesh, the mother socket which is created here, and the child one socket. With these three sockets you can manage all the tree. So I will do it from scratch. I will get, so you understand better what we are speaking about, I will go in the shapes and get, for example, select this, the pyramid. Usually what I do is I get the static mesh and I copy in my folder, in this case the one child folder, copy here, and now I have this static mesh. So what you have to do, the step you have to do to use the mesh in your fractal tree. First, you select the show pivot. When you have selected, you create a socket which is exactly in the show pivot location, and you name it pivot. The name is very important because with these names I will use these names in the code, in the blueprint code, as I will show you later on, and the fractal tree is generated using these socket names. Then I create another socket which is called mother, and it will be always called mother, and then another socket again which is called child 1. If you have binary trees, will be another socket called child 2, trinary trees child 3, so child 1, child 2, child 3, and quaternary trees will have 4 childs, so child 1, 2, 3, and 4. These are the only information you need. So let's see how it works, and let's see how it is flexible to create different fractal tree forms. Let's get the mother. So the pivot never moves, stays there always. The mother. Let's put the mother where you want in the shape, in the geometric shape. For example, it stays here very close to the pivot, so it's at the bottom of the shape and it stays here like this. Now we place the child. So I want to place the child. I select the child and I place it right on top here. Let's say not exactly on top, let's say here. What I do now is save. That's it. This is the secret behind all the fractal tree. Usually when I have a new sort of static mesh, not the Unreal Engine geometric shape, but a new one, I check also the collision. So I like to set the collision which is perfect here. Otherwise I create a new collision here. Usually I use this, the auto convex collision, and I put the parameters up to the top and I click apply. I don't need to do this because I have already collision. So this is done. I click save. What I do now, I have this mesh here. I just need to select my tree here and click the pyramid on the root, on the level 0, so here, and you see immediately it understands that the mother socket is on the bottom and the child is on the top. So this is the rule we have set. We want that each mother meets its the child, so in this case one child, and they meet exactly here, where there is the child. So here I set the child, and there is the mother of the next mesh. And that's for all the fractal tree. So this is the rule and the trick behind. And this is really useful when you do this kind of operations. So you add more levels, or you want to enlarge one level, for example, the third one. You want to, let's say, make all the operations of torsion and rotation and so on. So this is really useful. And see now, I put now the parameters back to 0. I put another, let's say, level where I put 2. See now how we can change this tree. Of course, we can move the tree. We can rotate the tree where we want. So we can rotate it also, and we can copy the tree if we want to do another tree. So let's copy like this with the Alt key, and then we can put the materials. I want a red one here, I want a silver one, metal one here, and that's it. So you see, it's very easy. If I click play to play this, so I have my 2 fractal trees. Let's cancel this, for example. Let's see how we can change the tree if we change these sockets. So for example, I want the child not to be on top, but to be on this vertex here, for example. And I want the mother, so I will get the mother, and I want the mother to be on the other side here. Now, even if I go a bit distant, you can put it also outside the mesh, it's not important. So I save. You don't see the difference immediately. You need to or to build again the scene here, which is slower, or to open the blueprint and compile it again. So you see, already you see the difference. We have put our socket, one on the corner and one on the other corner. So the fractal is created like this. Every mesh will be joined child mother in this way. And here you can create all the different, and you can also rotate and do all the operation as we have done before. And you can create all the different forms, also changing these kind of sockets. This is for the one level sockets. I cancel this. I want to show you just one part of the code, which is the blueprint is fully commented, so you will easily understand what is going on in every blueprint. And here in the function that creates one child, you see I understand the location of each point in the socket name pivot, mother, and child 1. So it's very important to keep these names when you manage the meshes. You see all the meshes here have the same pivot, mother, child 1. And also the cylinder here, pivot, mother, child 1. You can put them where you want. I usually put the mother at the bottom and the child at the top, so I have this vertical shape, but you can put it anywhere. For example, to do this kind of shape here, you see, is very interesting. I select this, and I put, as you can see, I put the mother on one side, the child on the other side. The pivot is always where there is the pivot location, and this creates this interesting shape, which we can rotate and makes this interesting geometric forms. The same thing is for this form here, the shape torus. I put here the mother in the center, right in the center. The pivot is a bit lower, and the child 1 is here on one side. This means that they will be connected in this direction, one another. You can also do this here, this kind of preview, but it's not the best thing to do, because it's not exactly how the blueprint is working. If you check then here in the code and we do some kind of torsion, you will see a nice chain effect that we can have when we do the rotation. So this is another good effect. It's really up to you to understand the best way to join the meshes. This is for one mother, one child. If we go to the binary trees, and is the same then for the trinary and quaternary trees that you see here, things are pretty the same. Consider 2 children, not just one. So the same thing as before, we select the static mesh. We are using this mesh here, the V static mesh, which I created with 2 cylinders. And here, like before, you see we have the pivot here in the center, where there is the show pivot. Then we have the mother. I set the mother at the bottom of this V mesh here. And the 2 children, I set one here and one here. So child 1 and child 2. And like before, if you see the create 2 children functionality, you see here I have the pivot, the mother, and the 2 children, child 1 and child 2. And this is how I catch all the location and the rotation and the scale of of the tree. So as the same way, if you want to do a new mesh, you can do the same way as before. For example, I got the cube as before, and I set the pivot in the center of the cube, the mother here at the bottom, and the two child 1 and child 2. If you see, I put also, I didn't not only move the children one on the side and one on the other side, but I gave them just some rotation. You see here, you can see from the preview here, I gave some rotation because I wanted to create this very cool tree here. So this is the mother and these are the two child, and then again you see the mother becomes this and then the two child. So if I do the same thing here, you see I get this cube, I put it here, and you see this tree coming up. You've got to play with the dimension of the levels. Of course, the first level is the biggest one, and then the second level, level 0 is the biggest one, then 1 is a little bit smaller, and so on. But if you increase the levels, you see this coming up, this kind of tree, which is the same of this, and here you see the right dimensions. So you can easily create all the fractals you want, and you can really adapt your sockets and find the best way to create different forms. For trinary trees and quaternary trees is basically the same as for binary trees. You need just to consider 3 children here and 4 children here instead of 2 children we had before in the binary trees. So let's see, for example, I go to the 3 children folder, I open here, and you can see that we have the pivot, still the same pivot. Then we have the mother, I put the mother on the bottom like the other binary trees, and then I set the 3 children, child 1, 2, and 3 on the 3 top here of the cylinders. That's it, nothing new. And when you check this kind of mesh, you see they have the same static mesh, and nothing different. So you can also here decrease the levels and increase them. Remember to define the levels here, so you need to add the levels here, and so on. I can also, for example, change this tree and put this cubic. I put instead of cylinders, I use cubic with the same sockets. So I could put on this tree the cubic one, the cubic shapes, and this is the effect. So I put the same static mesh to all the children. So we have the level 0, child 1, child 2, child 3, and this is the effect. Then you can rotate and you can do everything you have done in the other trees. So let me put back this here. And for the other for this tree is basically the same. The only thing I did on this tree is to put one child with another mesh and also the level 0. So you don't need to put all the same meshes, you can put different. But for quaternary trees it's still the same. We have this mesh here in the 4 children, so we have 2 meshes. This one is like all the other ones for child, so child 1, 2, 3, and 4. And you see this kind of tree we have. So we have 3 levels, and these are the dimension of the level. You can change the tree scale here, you can rotate and do all the rest of the things. Here we have some emissive materials. This is a different mesh and a different way to see the tree, and this is why it's so flexible, this blueprint. If you open this, you can see that I built this with 2 cylinders, 4 cones, and the sphere in the middle. I put the pivot where is asked, so in the center of the object of the static mesh, and I put the mother on top, which means that every child will be connected to the mother on this location here, and the 4 children, because it's a quaternary tree, the 4 children at the bottom of each cone here. And this is the effect you have. So if you put this mesh to all the root level and the 4 children, this is the effect. I show you for level 0 is this. Level 1, you see the fractal tree is created with this root. So this is the mother, and here you have the sphere is the mother, and here you have the connection between the child and the mother. So and if you go ahead, you see the propagation of this fractal tree. And here the same, you can rotate and so on. Be careful that when you increase the number of meshes of polygons of this tree, every operation becomes slower. So I suggest to put, for example, this one level and do all your rotation you want, and then after you have done the rotation, you increase the level again. So I can put here 3, and this is the final tree, which is much faster than doing the operation with all these polygons here. That's it. I put back level 2. Here I put the same mesh with a very small scale. You can see here, very small scale, 3 scale 0.17. This should be 1.7. And here I removed the collision because I wanted the player to go right into the mesh to see very closely how it's made. So you can use this also with the virtual reality, the Oculus Rift. I tested, and it's really good, and you can really see the mesh very closely. You have this emissive material here, and now let's go to the final 2 blueprints, which are the destructive and the animated fractals. So for these I have destructible trees. I have these blueprints here, 1, 2, and 3. I did one for each mesh I want to manage. This say I want to see the cube, this destructible tree. I open this, and you see now I'm connecting this add destructible component. So I'm adding to the scene this kind of component. So if you are doing your personal fractal tree and you want to do a destructible, you just need to duplicate this. Duplicate this destructible mesh, you open it, you go in the construction script, you go here and you add your mesh here, and then you connect this and this and this and this part here. Like you see here, you connect them and you have the same effect. How you do this kind of box here, it's very easy. You just need to go to the mesh folders. So in this case we are speaking about binary trees, so we go in the 2 children, and you see here we have the destructible mesh, this, and this, which are these 3 trees, the cube, the alien form, and the V mesh. So it works like this. You click on the right, you create a destructible mesh, and you have this kind of mesh here. Once you have created it, you select, you go in the blueprint. I go in the blueprint, I click add, and you go on the top, right on the top. Sorry, add destructible component. So you see the Unreal Engine is suggesting you this, and in this case I'm adding the destructible component of the mesh I was selecting, so this mesh. So you just connect this to as the same way as connected this box, and that's it. And you have your personal mesh connected, and the tree will be destructible in the same way. So how this is working is exactly the same of the binary trees. You have, as I said before, create the static mesh, the destructible mesh. You place them in where is asked here on the right panel. So you have the root, the level 0 with this mesh here, also the child mesh and the child 2 mesh because it's a binary tree, and then you put the same way you put the destructible mesh. So this destructible mesh you put in these 3 places, and then you do exactly the same. You choose the gravity. The gravity is here affects the explosion. If you select the gravity, the explosion will go down. If you don't select, the explosion will stay in there. So you see now it's go down. The alien has no gravity, so the explosion stays there in the air. Now I don't select the gravity, and it stays in there. So that's it. Last thing of the destructible mesh to keep in mind is that when you create your destructible mesh, so once again you go here on the static mesh, you click create destructible mesh, and you have this generated. When you have this, you just click fracture mesh, and it will create this animation, this kind of fracture. To make the fracture working, you have to flag this enable impact damage, and I choose the materials inside the destruction mesh. So I set this material as the object material, and this is the fracture material. This is an emissive material, and I put these in the package I created myself, and I put these in the package. So they are based on this material, and this is stanced the material for each color. very simple material. You can see here it's really 4 boxes. It's really simple material like this. And when you create the color, you just select the color red and the emissive amount you want. That's it for destructible trees. So the only thing to remember is this part of the construction script, this part here, which is the only part of the code you need to change to make it work, and it's highlighted in red. The last part is about the animated tree. So here I wanted to give some sort of animation to these trees. These are nothing to do with animations sequence or animation montage. These are rotation sequence. So I just got this tree here, which are all one mother, one child tree. There are no binary trees. I didn't do this. Perhaps I will do in a future volume pack, but not now. So if I click simulate, I see all the rotations, and if you see here from the fractal folder, we have 1, 2, and 3 animation blueprint. One for the X axis, one for the Y, and one for the Z. So there is one animation for each of the 3 axes. If you open the blueprint, you will see that these are just animation sequence that are going like this, and that's it. And in the construction script here, in the create one child here, where it is, here you can see that in the this is the X rotation, so I connect the X, so is connecting here. So in the rotate one child, if I open the Y rotation, I connect okay, I connect here the Y, so you see this is connected and this no. You see here I get the variable in-game rotate angle and I connect the Y, and in the Z rotation here I connect the Z. So from here, this variable is changeable from the editor in-game rotation angle, and you can see selecting this mesh here, we have the difference between the normal trees is this. We have the rotation angle and the rotation speed. So by changing these, you change the velocity of the rotation and the angle. The angle is, you see, 0.8 because every time you rotate one mesh, it will impact also the other mesh of the trees. So at the bottom is 0.8, but then it will increase, and this gives this kind of result. So for example, I put 1.5 and I put here 0.1 to make it slower. So you see, the rotation has increased, but it is slower. Let me change again. I put 0.3 to make it even slower, and here 1 to make a normal rotation, and it's going slower and it stays like this. And here you can play also with this. Of course, if you do this kind of rotation and at the same time you do also a torsion of the mesh or even a rotation of the mesh, the animation changes. You see, now it's going up in this direction and it's going in that direction. And here we have applied the the X rotation. So we could do also the Y rotation or the Z rotation. You have the 3 of these here, and they work the same way in the 3 axes. That's how it works. If you want to change the code and you want to do complex rotation with both axes, you just need to drag this, the angle, and you just need, for example, here is the X rotation. You put the angle also here, and you do both the X and the Y rotation. And there are 2 kinds of rotation in the same animation. That's it. Let me cancel this. For example, this is this kind of torsion here. You see it if I move it like this. I put the scale, 3 scale, I put 1 here, and you see this is the animation it does, so it's kind of torsion. And you see one important thing, the last one, and then we have completed this tutorial part, is this level scale and in-game level scale. So for each animation, you see that I have a level scale, which is the mesh scale. Let me get one one simple mesh like this. So we have the level scale, which we have here, 5 scales, and we have also the in-game level scale. The in-game level scale is the mesh that is identified in your in-game level. When you build this kind of animation, you have to be sure that the fractal levels is exactly the same or inside this level scale here. So if you put 6, you will not see anything because you don't have the 6th level here. You need to create it like this, and you need to give it a dimension also, and you see it's appearing. And when you do the animation, you don't have the 6th level here too, so you need to add this also. So you add this and you will see appearing this, and it's already identified. If I click play, it's working. The error can come if I add this here and there is nothing here. So you click play, it's still doing the animation, but when you stop you receive the error because it's trying to rotate a mesh inside the level, the game, so the in-game mesh, but there is no mesh there. So you just need to delete this and play again the level, and it will go without any things. So this level scale here, 7, has to be exactly the same of this. And if there is an error, go to check these and be sure that they are all filled with a shape. That's it. I completed this kind of tutorial, so again, it's up to you and to your imagination and creation. You see, it's very easy to create these kind of meshes. I thank you if you if you purchase the fractal tree, and I will put other tutorials if you will ask in the comments, and I will be working on a future volume pack with more animation and more shapes. Thank you all. See you in the next video. Bye bye.